we've been talking about populations, ANOVAs, and regressions, correlations, and all the rest. And what I'm going to do today is I'm just going to show you how we apply it and the type of questions we ask and the way we analyze the data. Now, I've been asked about different stats programs. And you'll find that most of the stats programs work on the same basis. I tried to download R, seeing everybody was asking about R, it wouldn't download. But I imagine it works on the same basis as all the rest. Now, I've got three programs that I use. The one is SAS. That's the one I've just opened up here. SAS is a very powerful stats package. Can do just about anything if you program it properly. So when I've got very large data sets or I want to do some fancy analysis, I use SAS. And I'll be quite often, I'm quite honest, I very seldom go into SAS. Okay, it's only when I do big analyses. The disadvantage of SAS, if I can just open one of my applications, it doesn't matter which one. The problem with SAS is you've got to tell it what to do. So you can put the data into the system, and if you eventually get down to the bottom of the data, pull it down. Yeah, well, I'm just, as you can see, it's a fairly big file. But what you have to do with SAS is you've actually got to give it instructions. Oh, clever. Well done. You've got to give it instructions, telling it what to do at various points. So you've got to give instructions how to read the data, what model to use, what order to use the data, and so on. So it can become quite a complex and difficult job to use the program. So normally when it comes to smaller data sets or everyday type of data sets, randomized block designs, that sort of thing, I either use GenStat or I use NCSS. NCSS is just a small program which does the everyday kind of programs. And I'm going to use them now, so then you'll see how they work. Now I want to just take a couple of scenarios to just show you how we can apply the kind of questions that we ask in stats and sort of show you a practical application of the things we've spoken about over the last couple of days. So I'm going to take a very simple situation to start with. I found rust in two varieties on adjacent plots. Does the rust in the two plots differ? Okay. In other words, you can ask another question. There are two varieties. Do the two varieties differ in terms of resistance to rust or the amount of rust that has developed on them? So what I did then is I took the field, I divided, or the plots, and I divided them up into 10 blocks, took 10 plants per sample, or in a block, and I determined rust severity. And I got the following data. I haven't got a mouse here, so anything can happen today. Okay, right. So there you have the different severities, field 1 and field 2. And then just to show you how you can use Excel, as we did before, to work out the averages. Which I'm sure you all know how to do. Okay, and you can work out the standard deviation. And those are the sort of things we spoke about earlier in the week. And I'm just going to copy and paste. Okay. So the mean of that plot was 25 and the mean of that plot was 45. Now the question is, do those means differ significantly? If you look at the data, there's a 41 and a 43, and there's a 47 and a 43. So, you know, there's a little bit of overlap in the numbers. So the question is, do those means differ? Now you can do that very easily on Excel. You can go to data and data analysis, and you'll see it gives you a couple of options. And down the bottom there, I've got a few options for t-test. There are a couple of options: unequal variances, equal variances. When in doubt, I always use equal variances. So I'm going to use that now. The range of the first data set is there. The range of the second data set should be there. Okay, and as an output range, I'm just going to say dump it there. Okay, and I say okay, and essentially it gives me the t-test. Now you can see, ooh, what's happened here?
You set the range.
Okay, did I set the wrong range? I was trying to speed it up, was I? Okay.
First range.
Okay, let's delete that all. Go back there. The first range, see, okay. As I always say to my students, if you're stupid, you've got to battle.
Yeah,
Okay. Right, try again. But as you can see, you don't need to do the fancy maths. You don't have to go and calculate all the deviations by hand and the sum of squares and so forth. You've got machines to do it for you. So there you've got the two means that I calculated earlier, the variance, the observations, pooled variance, gives you a whole thing. But the most important thing here is that value, 4.08. And it doesn't matter if it's negative or positive. And you'll remember at some point I told you about the t-table. Right, I haven't got 18 degrees of freedom on here, but you can see generally you're in the range of 2 point something. That is the critical t value. Now Excel is very clever. It actually works it out for you. If you're going to do a one-tailed test, it'll tell you the critical value is 1.7. Here it tells you 2.1. That value exceeds both those. So whichever direction you want to compare, okay, it tells you that those two means differ. So in other words, very simply, using Excel, using the t-test, I can conclude that those two varieties or those two fields or plots differ significantly. Okay. And I can say what's going on in the one plot is different to what's going on in the other plot. Okay. Simple, right, nothing to it. Happy? Right. Now let's go take it a step further. Right, you need to evaluate 9 lines for disease resistance, and I chose a lattice design. Why? Okay, I'm assuming that my environment is variable. Soil heterogeneity, or whatever the case may be, right? So I chose a lattice design, and I laid it out in blocks like this. There were 4 replicates, okay, and there are the 3 blocks in each replicate and the 3 rows, and the randomization of the varieties or lines. Right. So what I want to do is to analyze that. The easiest thing to do is to copy that and go and put it in GenStat. Oops. Let me close GenStat before I... okay, try again. The reason I close it there is it just cleans up all the registries and that sort of thing. Okay, so I now take the spreadsheet I copied from Excel and I can paste it into GenStat very easily. I just need to convert that to a factor. Okay, so there's my spreadsheet now in GenStat. Now GenStat gives you quite a few options under, try again. Gives you quite a few options under analysis of variance. If you go to general, you'll see it gives you from general analysis of variance, one-way, two-way, split plot designs, and all the rest. And I chose the wrong one there. The one I actually do want to use is lattice design using blocks. The Y-variate was whatever I measured, disease severity. The treatment is the entries. Replicates is replicates, and blocks is the blocks 1 to 12 that I had in the experimental design. Now I don't have to do, I've got options here as well. I can say I want to calculate the CVs, and most important, I want to calculate the LSDs and means. And all I say is run and go to the output. And there's all the information I need about my lattice square. So there's no difficult calculation involved. The program does it all for me. So here's my analysis of variance. And I've got my variance due to reps, but the most important ones, and blocks. And the most important one is entries. And you look at the variance ratio there, is 93. It's highly significant, which is telling me that those varieties or lines that I was testing differ significantly from one another. And somewhere it should give me means. Why can't I find the means? Ah, there we go. So they're the means of the lines. Line number 1's mean, line number 2's mean, and we go through to there, to line number 9. And if I go down a little bit, I did ask it to give me LSD values. There they are there. There's the important one that I want there, 9.3. And I can go back up here and I can compare my lines. So in other words, if a difference is greater than 9, as it is there, I can say that line number 1 differs significantly from line number 2. The difference needs to be 9. Line number 1 does not differ from line number 3 because the LSD, or the difference is not greater than 9. Those two differ, and you can then work out the different permutations. And that one there you can see has the lowest value. Okay. So that is a very simple way of working out then, or answering the question, do lines differ in terms of disease resistance or whatever it was that I was measuring? In this case, disease resistance. It can be yield, it can be anything, plant height, whatever the variable is that you want to measure. Okay. And you have your answer very simply in GenStat. And you'll find that most of your stats programs can do that kind of analysis. I just like GenStat for things like this.
Is it a free resource?
No, unfortunately not. It costs you roughly £120. But now, I didn't check this. GenStat does have a program for developing countries. And certain countries, the first time I used GenStat, they regarded South Africa as a developing country, and I could download it for free. But once they had me hooked, then they sent me an account. Okay, so now I have to pay for it. So now it costs me about 120, 130 pounds a year. Okay, which is not the end of the world. Okay, and it's a very useful program, and it's worth it.